Yes, hello friends, welcome to the session. I am discussing chapter 7, DC bridges and AC bridges. In the last session I discussed about classroom workbook based on the DC bridges. Now we will start the new concept in the chapter 7, that is AC bridges. Okay. This I am discussing as a 7.2 as a AC bridges. Okay, that 7.1 I discussed DC bridges. This I am discussing as a 7.2 as a AC bridges. Foot siding AC bridges. I already told that whatever may be the bridge, it may be AC bridge or it may be DC bridge. The principle is which one? Null deflection. Even AC bridge also works on the principle of null deflection. Yes, but all the AC bridges are outgrowth from DC bridges only. That's why the reference bridges for AC bridges also DC bridges, that is a Wheatstone bridge. In the DC bridges, we can replace the arms by impedances, source by AC source, and based on the frequency we can use some detector, then it becomes a AC bridge. That's why all the AC bridges are outgrowth from the DC bridges only. That's why the basic bridges are DC bridges. Okay, it may be AC or DC bridge, it works on the principle of null deflection. Yes, now the question is, for the operation of any AC bridge, what are the basic requirements? The first you concentrate basic requirements for operation of any AC bridge. Okay, this I am giving some introduction. Basic requirements of AC bridge. This I am giving basic requirements of AC bridge. To operate any AC bridge, what are the basic requirements? Yes. One is, for the operation of any bridge, one is it must require the source. It must require some source. Then what is the source we are using in AC bridge? For low frequency application, for low frequency or at power frequency. Once we are using the AC bridge at power frequency or low frequency, AC power line is used as a source. For low frequency, okay, and at power frequency, yes, AC power line is used as a source. AC power line is used as a source. Okay, this point you remember. This is a selection of source. But the same bridges can also be used at high frequency. Then what about at high frequency? At high frequency, an electronic oscillator is used as a source. An electronic, yes, oscillator is used as a source. Oscillator is used as a source. At high frequency, an electronic oscillator is used as a source. Okay, then there is some advantage are there using the oscillator as a source. There is some advantage are there using the oscillator as a source. One advantage is, what is the advantage of using the oscillator? One is, the oscillator frequency is maintained as a constant and adjustable for any frequency. We can maintain frequency as a constant or we can adjust for any frequency. We can maintain frequency is constant and we can easily adjust the frequency. Yeah, this is one advantage. The output waveform is the shape of the output is nearly sinusoidal. Okay, shape of output is nearly sinusoidal. This is another advantage. The output power of the oscillator is sufficient to operate any bridge. Okay, the output power is sufficient, having sufficient output power to operate any AC bridge. Okay, because of these advantages, we are preferring oscillator. Okay, but point to remember, a typical oscillator having the frequency range of, you select the one of the rating of the oscillator is a typical oscillator having the frequency range of 40 Hz to 125 kHz with power output. The rating of power output is 7 watts. This is one of the rating of the atypical oscillator. For normal measurement like inductance, capacitance, in these measurements, for normal measurement, what type of oscillator is preferable? For normal measurement, an oscillator with a 1000 Hz frequency, and power output and output power rating is 1 watt is used. This is the oscillator you prefer for normal measurement like inductance, capacitance measurement. For specialized measurement in special applications, for special measurement or for specialized measurement, then what type of oscillator we can use? The frequencies with adjustable frequency. We can adjust for any frequency with adjustable frequency, and power output is 5 watt rating. With adjustable frequency and power output of 5 watts is preferable for special measurement. Okay, this is the selection of a oscillator to operate the AC bridges at high frequency. Oscillator is used as a source at high frequency, but for at low frequency and power frequency, which is preferable? Yeah, AC power line. Whatever the supply is available, 230 volts, 50 Hz AC supply, that is directly is used as a source. Clear? Okay, this is one basic requirement of operation of any AC bridge. The another basic requirements of operation of any AC bridge is detector. We also use the detectors. The purpose of using detector is to identify the balance condition. That is, it indicates balance condition, or to identify balance condition we are using the detectors. To identify balance condition. Detectors are using in the bridge. We can use so many detectors. One is vibration galvanometer is used as a detector. Vibration galvanometer is used as a detector. Vibration galvanometers is used as a detector. These are used for 5 Hz to 1000 Hz. Even though we can use up to 1000 Hz, but more preferable below 200 Hz, 200 Hz, and at power frequency. For power frequency, the more preferable detector is vibration galvanometer, and which indicates the balance condition visually. That means the deflection of a pointer directly indicates the balance condition. If the galvanometer deflection is 0 in any AC bridge, then we can say that that bridge is balanced. That's why it indicates the balance condition visually. Then one more detector we can use, headphones. Headphones also used as a detectors. These are also called telephone detectors. Telephone detectors. Headphones are telephone detectors are used as a telephone detectors. Is used as a detectors. Then these are used about 250 Hz and up to 3 kHz to 4 kHz. 3 kHz to 4 kHz. These are used about 250 Hz and up to 3 kHz to 4 kHz we can use. Okay. But if you use the headphones, the balance condition is sensed not visually, orally. Just by listening the sound, if the sound is minimum or 0, then we can say that bridge is balanced. I think all are operated, all are done measurement lab in our colleges. Yes. Then how we are sensed the balance condition of a bridge? In some colleges we are used vibration galvanometers. In some colleges they are using the headphones also detectors. Once we are using headphones means it is not visually, orally we can sense the balance condition. Understood? That headphones are used about 250 Hz and these are used up to 3 kHz to 4 kHz also we can use. Okay, this is the headphones. The one more detector is tunable amplifiers. Tunable amplifiers also used as a detectors. Tunable amplifiers. Okay, tunable amplifiers also used as a detectors. Then these are used for a frequency range of 10 Hz to 100 kHz. These are used for wide range of frequency. 10 Hz to 100 kHz these are used. Okay, tunable amplifiers. Okay. Then in some applications CRO is also used as a detector, but these are used for greater than or equal to 5 kHz. For greater than 5 kHz CRO is used as a detector. Okay, these are the two basic requirements for operation of any AC bridge. One is it must require source, then what type of source we can use, then how to select. The another one is detector, then what type of detector. Based on this also competitive exam questions are there. In one side, in matching questions, in one side they are giving the detector names, in another side they are giving the frequency range. Match the following. And simple objective questions also it is framing. A telephone detectors are used for a frequency range of headphones, that is headphones are used for a frequency range of vibration galvanometers are used for frequency range of. That type of questions already asked in competitive exam. That's why don't neglect this. This is also important for competitive. Even though it is introduction, it is important as a fundamental. Okay, then we can expect what is the rating of the typical oscillator. Then for normal measurement, which type of oscillator is preferable? For special measurement, which type of oscillator is preferable? Then what is the advantage of using the oscillator circuit? Okay, these points you remember. Okay, this about what is the basic requirements of operation of any AC bridge. Yes. Now, before starting the in detail about each AC bridge, I want to explain what are the applications of AC bridge. That you concentrate. Write down applications of AC bridge. Okay. Here I am discussing some applications of AC bridge. AC bridges. One of the application is to measure. This is main applications to measure inductance, capacitance, mutual inductance, frequency, S, loss angle, dissipation factor, quality factor, power factor. All these are measured by using AC bridges. And these are also used to measure properties of insulating materials. To measure properties of insulating materials. Insulating materials. This is one more applications of using AC bridges. Then in communication system, to measure the frequency of audio frequency signals. To measure frequency of AF signals. Frequency of AF signals, audio frequency signals. And these are used as a distortion analyzers, in harmonic distortion analyzers, okay, are used in distortion analyzers. AC bridges are also used in distortion analyzers. Distortion analyzers. And these are used as a feedback circuits in oscillators. Take one of the example is Wien bridge oscillator. In Wien bridge oscillator, Wien bridge is used as a feedback element. In some electronic circuits, mainly in oscillators, used as a feedback circuits. Used as a feedback circuits in oscillators. Circuits in oscillators. Okay, these are some applications of AC bridges we are using. Okay. Now with this knowledge, I am giving some introduction. Now with this knowledge, now we'll start with the first concept with respect to AC bridges is basic form of AC bridge circuit. Generally, what the basic form of AC bridge will consist. For balance of bridge, which conditions must be satisfied? That I want to discuss. Clear? Understand? That you concentrate. Quick note down. Yes. Over. Now it's the basic form of AC bridge circuit. Now see the basic form of AC bridge circuit. Yes, mainly in any AC bridge, in general, bridge means it consists of 4 arms. Okay, this is a general representation of bridge. Can draw this parallelly, don't wait. It consists of 4 arms. That this is Z1. Sorry, correct this. This is Z1. Next, let's take this is Z2. This is Z3. And this is Z4. And this is detector. This is source. AC source we are using. Okay. Let this current is I1. This current is I2. And this is I3. And this is I4. Okay. Now this is A, B, C, D. The source voltage is E. That means in general AC bridge consists of 4 arms. Okay. Let this voltage is E1. This voltage is E3. S, and this voltage is E2. And this voltage is E4. Okay. Let the current through the detector is ID. Okay, this is the basic form of AC bridge circuit. This consists of 4 arms, 4 nodes, 1 detector and 1 source. General form is like this. Then whatever the balance conditions I am telling here, balance condition I am telling, that condition is applicable if it is consist of 4 arms only. Some bridges may consist of greater than 4 arms also, but if you want to apply the balance condition in that bridges, again you convert into 4 arms, then only you can apply the balance condition. Tell me. Just by seeing the bridge, can you tell me how to say that bridge is balanced? How to identify bridge is balanced just by seeing the bridge? Yes. If at balance condition, at balance, if the current through the detector is 0, then we can say that bridge is balanced. When the current through the detector is 0, you tell me, when the current through the detector is 0, yes. If the potential difference between these two nodes is 0 or VB equal to VD. If ID equal to 0 means VB equal to VD. The voltage at node B and voltage at node D is equal, the potential difference becomes 0, then there is no current. For the flow of current, there must be some potential difference. But if EB equal to VD means there is no current through the detector. Clear? Now tell me. If VB equal to VD means VAB equal to VAD, then only VB equal to VD, or VBC equal to VDC. Any condition will satisfy. That means VB equal to VD means VAB equal to VAD, or VBC equal to VDC. That is also correct. VBC equal to VDC. That means what these conditions indicates? Voltage across adjacent arms is equal. Voltage across adjacent arms is equal. Voltage across adjacent arms is equal. These are not the different conditions. All these are one condition only. If this condition is satisfied, then this also satisfied. If this condition is satisfied and this condition is also satisfied, that is the meaning. That means if the bridge is at balance condition, current to the detector is 0. Current to the detector is 0 means voltage across adjacent arms is equal. Voltage across adjacent. This voltage is equal. This voltage and this voltage. Then only current to the detector is 0. That is the meaning. Understood? Now, VAB equal to VAD means I1 into Z1 equal to VAD, that is I2 into Z2. Or you also write the condition like this: I3 into Z3 equal to I4 into Z4. I3 into Z3 equal to I4 into Z4. This is at balance condition. Now, at balance condition, there is no current through the detector. Once there is no current through the detector means this is open circuited. Once detector arm is open circuited means this Z1 and Z3 is, if this is open circuited, there is no current, these two comes under series, and Z2, Z4 is also comes under series. That means at balance condition, I am writing the equivalent like this. Okay, this is Z1 and this is Z3. This is Z3 and this one is Z2. Z1 and Z3 is series, and Z2 and Z4 is also series, and these two also series. Okay, and this impedance is Z2 impedance, and this is Z4 impedance. There is no current through the detector. Here we are applying the source. This is I1, this is I3, this is I2, and this is I4. Okay. Now, therefore, at balance condition, I1 equal to I3, because these two are series. I2 equal to I4. Shall we write like this? I1 equal to I3 equal to how to write these currents? You tell me. What the total voltage we are applied? E voltage. This is two parallel branches now. These two parallel branches means voltage across this branch is E. The voltage across this branch is also E. Now I want to define I1 equal to I3 equal to E by Z1 plus Z3. Z1 plus Z3. Similarly, how to write I2 equal to I4 equal to E by Z2 plus Z4. Z2 plus Z4. Now you substitute I1 in this equation and substitute I2 in this equation. Sorry, you substitute I1 and I2 in this relation. Then what you can get? Can you write like this? E into Z1 by Z1 plus Z3 equal to, that is E into Z2 by Z2 plus Z4. Shall you write like this? Z1 by Z1 plus Z3 equal to Z2. This is the condition at balance. This is one more condition. This is not a different conditions. Okay, if one condition is if it is satisfied, remaining all conditions are satisfied. If this is satisfied, remaining all the conditions will satisfy. That is the meaning. Therefore, at balance, Z1 by Z1 plus Z3 equal to Z1 by Z1 plus Z3 equal to Z2 by Z2 plus Z4. Okay. Now, you cross multiply this, what you can get? Z1 into Z2 plus Z1 into Z4 equal to Yes, Z1 into Z2 plus Z2 into Z3. Then Z1, Z2, Z1, Z2 cancel. Then what you can get? Z1, Z4 equal to Z2, Z3. This is very important condition to solve the problems in any bridge. In AC or DC bridge, to solve the problems, this is important condition. Z1, Z4 equal to Z2, Z3. That means at balance, very important, at balance, product of opposite impedances are equal. Product of opposite impedances are equal. Product of opposite impedances are equal. This is at balance condition. Z1, Z4 equal to Z2, Z3 means this is Z1, Z4. At balance, Z1, Z4 equal to Z2, Z3. Product of, to solve any problem on the, mainly to solve the any problem on the AC bridges or DC bridges, this condition is important. Okay. But from this, I want to write one more condition also. Z1, Z4 equal to Z2, Z3 means, we also write like this, Z1 is written as admittance 1 by Y1. 1 by Y4 is equal to 1 by Y2 equal to 1 by Y3. Shall we write like this? Y1, Y4 equal to Y2, Y3. Not only product of impedances. If admittances is equal, then only we can say that bridge is balanced. Okay, either impedance is product is equal or admittance product is equal, bridge is balanced. Okay, but you know that impedance is a which term? It is a complex term. Impedance 2 plus J2 ohms, 3 minus J3 ohms, like that. Generally, impedance is a complex term. Okay, then any complex term can be represented in two coordinates. One is rectangular coordinates, another one is polar coordinates. Now I am writing this impedance in the polar coordinates. How to write impedance in the polar coordinate? You tell me. Modulus of Z1 at angle of theta 1, modulus of Z4 at angle of theta 4 is equal to modulus of Z2 at angle of theta 2 into modulus of Z3 at angle of theta 3. Okay. Now one condition is modulus of Z1 into modulus of Z4 equal to modulus of Z2 into modulus of Z3. This is one condition. This condition is called magnitude condition. This is magnitude condition. This is called magnitude condition. Okay. But in product angles are added now. This is theta 1 plus theta 4 equal to theta 1 plus theta 4 equal to theta 2 plus theta 3. Theta 1 plus theta 4 equal to theta 2 plus theta 3. Then this condition is called phase condition. Phase condition or angle condition. That means for balance of any AC bridge, there must be two conditions must be satisfied. One is magnitude condition and the other one is phase condition. If any one condition is not satisfied, bridge is unbalanced. This is important observation. Therefore, you write as a note you write, for balance of AC bridge, both magnitude and phase condition must be satisfied. Phase condition must be satisfied. Okay, this you note down. For balance of AC bridge, both magnitude and phase condition must be satisfied. Continue that one. If any one condition is not satisfied, you note down that. If any one condition is not satisfied, bridge is unbalanced. Even if magnitude condition is not satisfied or if angle condition is not satisfied, bridge is unbalanced. Like this, we can identify the bridge is balanced or not if the impedances are given. Clear? These are the points you remember in the basic form of AC bridge circuit. Clear? Understand? That you concentrate. But here, I want to explain 2 points here. Listen please. Many important points. Okay, this is the basic form of AC bridge circuit. Okay, this is the basic form of AC bridge circuit. Here I am connecting detector is between B and D terminals. Source is between A and C terminals. But don't think like this. Always you can connect source must be A and C and detector must be B and D. That is not the way. Okay, that is not the rule. Always you can connect source is between A and C and detector is between B and D. Okay, there is not that type of condition. We can connect like this also. Okay, you can connect detector between A and C and source is connected between B and D terminal. Source is connected between B and D terminal. This also bridge circuit. This also AC bridge circuit. But don't connect source and detector for the same terminals. That is important here. That means, for example, I am connecting the source is between, detector is between A and C. I am connecting the source also between A and C. I am connecting source also between A and C. If you connect like this, the bridge never be balanced. Why? Always the voltage across the detector equal to source voltage. For the balance of bridge, the voltage across the detector must be 0 now. Is there any possibility that voltage across the detector must be 0? Unless otherwise supply is switch off. Understood? That is mean. That's why don't connect the detector. Don't connect source and detector for the same terminals. If it is connected, the bridge never be balanced. That one point to remember. For example, let us assume that I am connecting the source between A and C terminals. Detector is between B and D terminals. I connected like this. Now by varying some parameters, I am bringing that bridge is balance condition. Now let us assume that bridge is balanced. Now at balance condition, now what I am doing means I am interchanging the detector and source terminals. Now I am connecting the detector in between A and C terminals. Source is between B and D terminals. Now I am interchanging the terminals. Then balance condition will not be affected. Still bridge is under balance. Even though you can interchange the terminals at balance condition, still the bridge is under balance condition only. This is according to reciprocity theorem. It is according to reciprocity theorem. What the reciprocity theorem states, even though excitation and response is interchanged, the ratio of response to excitation remains same. Now which is the response here? Detector output. Which is the excitation here? Source. Clear? These 2 points you remember. You write as a note. Write as a note. First one. Don't connect source and detector for the same terminals. Don't connect source and detector for the same terminals. Source and detector for the same terminals. This one point you remember. Same terminals. Continuation you write. If it is connected, bridge never balance. If it is connected, bridge never balance. The second one. At balance condition, if the source and detector terminals are interchanged, if the source and detector terminals are interchanged, balance condition will not be affected. Balance condition, that means still bridge is under balance. Balance condition will not be affected. Condition will not be affected. It is according to reciprocity theorem. It is according to reciprocity theorem. Okay, these 2 points you remember. At balance condition, if the source and detector terminals are interchanged, balance condition will not be affected. It is according to reciprocity theorem. Okay, this about the basic form of bridge. Now with this knowledge, we can solve first model of questions in the AC bridges. The first model of questions. This model of questions already asked in all the competitive exam. See, the first model of questions is, here they are giving one bridge circuit. In that bridge circuit, one is check the balance condition of a bridge. That is one model. That is one type of question. The another type of question is asking, here one bridge circuit is given, one is unknown impedance is given, calculate unknown impedance at balance condition, identify the elements of unknown impedance and calculate the value of unknown values, calculate the values of elements. This type of models of questions are asking. To solve this type of model, no need of in-depth knowledge on each bridge. Just with this knowledge, we can solve that model of question. Okay, but you remember one note also. You solve the model 1 questions, you remember that note also. Here I will give that note and I will solve the one question, then you get idea. But in detail, in 1 or 2 questions, I will solve even in the classroom workbook also. But here for understanding the concept, here I am giving 1 or 2 questions that you will see. Okay, now see, to solve the model 1 questions based on this topic, this note also you remember. Okay, remember as a note, element, angle. If it is resistive element, angle is 0 degrees. If it is pure inductor, plus 90 degrees. If it is pure capacitor, minus 90 degrees. If it is R and L, 0 to 90 degrees. If it is R and C, minus 90 to 0 degrees. Okay, this one note you remember. But here I am telling that R and L, 0 to 90, R and C, minus 90 to 0. But either series or parallel, it is applicable. Series or parallel, 0 to 90 only you take. If R and C is given, both series and parallel also it is applicable. Series and parallel. Sir, if both series, RL series and RL parallel both are given in the option, then which one you can select? RC series and RC parallel both are given, then which you can select? If RL series and RC parallel, RL parallel both are given, if the option is RL, answer is RL elements. If both series is given and parallel is given, then you give the preference to series only in RL combination. Okay, both RC, but option answer is RC element, but RC series is given, RC parallel is given in the options. Then which one you can select? You can, in RC combination, RC parallel is preferable. If only one is given, that you can select, no problem. If both are given, then you are confusing. Then in RC combination, parallel is preferable. In RL combination, series is preferable. That you concentrate. Okay. Now to calculate the elements, then you remember this: R equal to modulus of Z cos theta. Then XL equal to XC equal to modulus of Z sin theta. Okay, how to write XL equal to omega L, that equal to 2 pi FL. This you know. How to write XC equal to 1 by omega C, 1 by omega C, that equal to 1 by 2 pi FC. Okay, this you remember to solve the first model of questions. For example, if the circuit is given like this, if the bridge circuit is given like this, okay, let this is Z1, let this is Z2, Z2, and this is Z3, and let this is ZX. And this detector is this one. Let this is 10 at angle of 30 degrees, and this is 20 at angle of 40 degrees, and this is 10 at angle of 20 degrees. If it is given like this, then source is given as with a frequency of 100 radians per second. Okay, can calculate ZX. This is one question. Calculate ZX. Then identify elements of ZX. Identify elements of ZX. Elements of ZX. This is one more question. Calculate values of elements. Values of elements. Values of elements. Okay, these three models we can expect. Then calculate value of ZX means this is at balance. The question is framed at balance condition only, no doubt at all. It is asking at balance. Then at balance, product of opposite impedances are equal. Yes, this is Z3, this is Z1, Z2. Product of at balance, product of opposite impedances are equal. Then what is the product of opposite impedance? 10 at angle of 30 at balance. At balance, 10 at angle of 30 into ZX is equal to 20 at angle of 40, 20 at angle of 40 into 10 at angle of 20. Okay, then what is ZX equal to? 200 at angle of 60 degrees by 10 at angle of 30 degrees. Then what is ZX, you tell me? 20 at angle of 30 degrees. This is the unknown impedance. If impedances are given in here directly, it is given in polar problem, polar form. That's why easily we are getting. Even we can expect in rectangular form also. You convert into polar form, then we can easily solve. Okay, this is unknown impedance. But what is unknown impedance angle? We are getting 30 degrees. It is in between. It is 30 degrees is in between 0 to 90. If the angle is 0 to 90, then hence elements of ZX is, R and L. Okay, that is identification. Because I am getting 30 degrees. For example, you are getting here minus 30 degrees. What is your answer? R and C. I am getting plus 90 degrees. What is your answer? Only L. I am getting minus 90. What is your answer? Only C. If you get minus 90. You are getting 0. What is the answer? Only R. Like that you identify the elements. Once we are identifying the elements of ZX, then how to calculate? R equal to modulus of ZX cos theta. What is ZX? 20. Cos theta, cos 30. Root 3 by 2. That is 10 root 3 ohms. Then how to calculate XL? We know that XL equal to, that is XL equal to modulus of ZX sin theta. XL is nothing but omega L. Modulus of ZX sin 30, 1 by 2, 10 ohms. But I want L, 10 by, how much? Omega is given 100 radians per second. 10 by 100. how much we get? 0.1 Henry. Like this we identify. Clear? Like this we can identify the elements and we calculate the impedance and we calculate the inductance. For example, in the same model, this also given, let this is Z4 and it is given that 20 at angle of, it is given that 20 at angle of 45 degrees. For example, identify the balance condition of a bridge, it is asked. Check the balance condition. Check the balance condition means 10 into 2200, 10 into 2200. Yes, magnitude condition is satisfied. 30 plus 45, 75, 20 plus 40, 60 degrees. Is it phase condition is satisfied? No, bridge is unbalanced. That is the second model of question. All the impedances will give and check the balance condition means you take the both magnitude and which condition? Phase condition. If both the conditions are satisfied, then only bridge. But if it is in this problem, if it is given like this, can you check the balance condition is bridge is balanced or unbalanced? Unbalanced. Why? 10 into 2200, 10 into 2200. Yes, magnitude condition is satisfied. Then what is the angle condition? We can add angles in multiplication. 45 plus 30, 75. 20 plus 40, 60. Is it phase condition is satisfied? No. That's why bridge is unbalanced. Like that you answer. Okay. Now sometimes the problem is framing by giving the sources also. By giving the sources also, the problem is framing. But for example, yes, if it is given like this, I am giving one more example. All this will solve even in the classroom workbook also. We'll see. This is one source it is giving. And this is the detector. This is another source. Okay. Let this is ZX. Unknown impedance. Let this is 100 sin 100t, 100 sin 100t. Yes, this is 100 sin 100t minus 30. This is let 10 sin 100t minus you take 100 sin 100t minus 30. This is 100 sin 100t. Okay. Let this resistance equal to, this is 10 ohms. Now if it is asked, what is the elements of ZX? Elements of ZX. One more question I am framing here. If it is asked, what is the elements of ZX? Okay. Simple. One method is actually, once you are solving in objective point of view, directly we can do like this, product of opposite impedance. From that we can identify ZX. Then what is ZX into, this method we can solve maximum in objective point. Descriptive point of view, don't apply this one. Okay, because sources are there na, then you go for another method. Okay, then ZX into 100 sin 100t minus 30 is equal to 10 into 100 sin 100t. Okay, now from this what is ZX, you tell me. ZX equal to, then ZX equal to, then 10 sin 100t by sin 100t minus 30. Sin 100t minus 30. Now ZX is nothing but a VZX by IZX na, VZX by IZX. Then this is current, this is voltage. Now from this what is the observation? IZX lags VZX by 30 degrees. IZX lags VZX by 30 degrees. If IZX lags VZX by 30 degrees means hence elements of ZX is, what is the elements of ZX, you tell me. The elements of ZX is, lagging means one element must be inductor, but is not exact 90 degree lagging. That's why R and L. Over. Then if it is asked, what is the R value? R equal to modulus of ZX into cos theta. What is ZX? ZX is 10 ohms. sin theta, modulus of zx cos theta, cos 30. That you solve, then we get 5 root 3 ohms. Then what is XL equal to modulus of zx sin theta? Zx is how much? 10, sin 30, 1 by 2. What is XL is omega L. Omega is how much it is given? 100. Yes, 100 into L equal to 5. Then what is L equal to 0.05 Henry. Like this we can solve. Okay, this is the method you follow. Then directly I am applying product of opposite. Sir, here the sources are given, how we can apply product of opposite impedance. Yes, these are the arms is nothing but you are treated as a impedance only. You can apply the product of like this means then in product the volts will be cancelled, impedance that will be constant only. That's no problem. Okay. No sir, I want to solve the another method means you go like this. Voltage across this arm equal to voltage across this arm. Because voltage across this arm equal to voltage across this arm. Because at balance condition voltage across adjacent arms is equal. Na? Then from this we can calculate what is this current. Okay. You calculate current in this arm means this by this. Okay. 100 sin 100t minus 30 by 10 ohms will give this current. Okay. Then this current is equal to this current. Then we can get IZX. Because this current is equal to this current. We can get IZX. Then voltage across this arm is equal to voltage across this arm. Then VZX you know. IZX you know, VZX you know. From that you can tell. Understood? See, for example, I am giving what is I equal to 100 sin 100t minus 30 by 10. Because this voltage is equal to this arm voltage. Okay. Then we can get 10 sin 100t minus 30. This is equal to IZX. This I equal to IZ because this current, because bridge is at balance condition, there is no current to the detector. This current only flowing in this arm. What is VZX equal to 100 sin 100t? From this also we can say that that current lags the voltage by angle of 30 degrees. Then what is the elements of ZX? R and L. Okay, this is one concept in the AC bridges. Okay, this is a fundamental concept. In the next session we will continue with the types of AC bridges we are using. Okay, thank you.